Thank you, Steve, and also I'd like to thank the Chamber for the chance to tell you about Camel City Solar this morning. As Steve mentioned, we are a spin-out from the Wake Forest University Center for Nanotechnology and Advanced Materials, and we were also named one of the top 10 renewable energy breakthroughs in 2010 by the Energy Resource. Also, energy consumption is very important. Over the next 20 years, our consumption will grow from 15 terawatts to almost 32 terawatts. That's 32 billion kilowatts. In roughly $1 a watt, that's a $32 trillion market. Now, the problem is we cannot save our way out of energy. I mean, we have to produce energy. So if you look at the sources where we can get renewable energy, fossil fuels are not going to be able to sustain us. Wind has potential, but the number one area where there's a lot of renewable energy is in solar. Now, what's the big problem with solar? If you ask what's the number one problem, traditional solar cells aren't very efficient when the sun's not shining. The next problem is the cost. Traditional solar cells have been very costly. You've also probably heard of some of the shakeup in the solar. The largest company a few years ago was Q-Cells. Q-Cells run into a lot of competition and issues, and now they're being restructured and bought by a Korean company called Hanwha. The other one you've probably heard a lot about is Solyndra, which is had great technology, but they didn't have a good business model. It cost them about $6 a watt to produce, and they were selling it for $3, so it was not sustainable. So what you have to do is, for these new technologies, they have to be brought to market with a reimagined business model. Also, the technology requirements have changed. In the past, everybody thought you could go to market with a 10% efficiency. But that's not true. It's going to have to be greater than 20% in efficiency. Has to last for more than 30 years. And it really has to be from earth-abundant materials, because materials like cadmium telluride, there's a lot of concern about how are you going to recycle, or you're putting a lot of toxic substance into the market. So our technology is a radical approach, as Steve mentioned. It's based on 3D. You can increase absorbable materials a few percent, but with 3D technology, you can increase it 100%. So basically, in a traditional solar cell, the light is, a majority of it is either reflected off or unabsorbed or converted. If you can imagine, in our 3D technology, it's like a tin can. The light comes into a tin can and cannot get out and gets converted. So you have a much higher conversion. Also, 3D yields more power over the course of the day, because really a traditional flat panel solar cell is really only efficient at 12 noon. We're actually more efficient at oblique angles of the sun, so at 10 and 2. So this yields roughly 2 to 3 times more power generation over the course of the day. The other thing we've developed with our technology is we're using earth-abundant materials, which are copper, zinc, tin sulfide. They're also very cost-effective. One of the big problems is, you've heard, like in SIGs or in most solar cells, they use indium. The Chinese control or maintain about 80% of the world's indium supply. So therefore, for us to be competitive, we have to look at other materials. Our CZTS ink is also based on a nanoparticle ink, and you can see on the left side where we can actually print it, spray it down, and then through the annealing, we get a very good absorber. We have a very good, experienced team. Our scientists are in the top 10 most cited. We also, with our experience, we have more than 100 years of experience in lean manufacturing and global commercialization. Thank you.